Hello, this is John Cranner. I'm a structural engineer based on Benny, and this is the third of my videos in cracking and movement in buildings. And finally, two finalists. Firstly, it's been 3 months since my last video, so if you've been in anticipation of this third one, sorry, but I've just, I don't know, been doing other things. And the other finally is that finally we're getting down to the nitty gritty of talking about movement. And as the title suggests, this time we're going to talk about the BRE Digest 251, which is entitled Assessment of Damage in Low-Rise Buildings. It's mainly, well, as far as I'm concerned, it's mainly about how you measure and record the cracking in buildings. Not only the cracking, the movements. So it shows you how to record cracking, out of plumb of walls, and also the out of level of floors, or the damp proof course. And as I may have said before in the previous video, the BRE digests are something that, if it's applicable to cracking building movements, it's something that all structural engineers and certainly building surveyors should be aware of and are legally required to. So if you were up in court for some case and you were talking about, and you made no reference to, well, specifically the BRE Digest 251, and you were making assessment of movement in buildings, then the opposing barrister is going to say, well, Mr. Cranner, didn't you not know about the existence of BRE Digest 251? And obviously in this case, I am, because I'm going to be talking about it. But if you say, no, I didn't know anything about it, then he's going to poleaxe you, basically. And interestingly, about this time last year, I was on an SPAB, the Society of Protection of Ancient Buildings course, talking about surveying of traditional old buildings. And I did ask that the surveyor who is, and he's very good. He's a good surveyor, and his expertise is in old buildings. And I did ask him, do you assess cracking and movement in buildings to BRE Digest 251? And he said, no, he didn't. I didn't press him any further, but I was just really surprised that he said he wasn't. He's an RICS surveyor, and he said he wasn't applying that. Anyway, when I was giving a lecture about cracking nearly 2 years ago now, I did say that there was a time when I was very negative and against surveyors because I thought they were all a load of rubbish. Because about that time, 15, 20 years ago, I was, well, more even 25 years ago, I was getting lots of follow-up surveys from surveyors who had just basically no idea what they were looking at. And I thought, well, that, all surveyors are like this. They'd have, and there was even one where the surveyor said there was cracking in the building. I looked all over that building for some form of cracking or movement, whatever, and I couldn't find it anyway. Now, I was working for a national firm that give out instructions to lots of local engineers. They call Specialist Express. That's no great secret that that's what their name and who they are. And when I came back, I rang up the head office and says, look, I think it's both a disservice to me that I've gone out and wasted my time, but also to our client who's spent this money on getting me to do the report. I really think you should say something to the surveyor about that. And they said, oh, no, we can't do that because he gives us lots of work. So I was forming this very negative view. What I really found out was that I got all the surveys from those surveyors who didn't know anything about it, but it didn't mean that there were surveyors who did know what BRE does. And over the years, certainly being on a Facebook group called the Surveyors Community Hub, I think that's the name. I found out that lots of surveyors do know about BRE Digest 1 and they do apply it. So that's heartening to hear. So what I'm going to be doing for the bulk of this video is doing a recording of a PowerPoint presentation because I can show more of the slides and photos easily. And then at the end of it, I'll just come back with this uh, video, face-to-face video, and or just face video, and then just do a wrap-up talk. Now we have the opening page, the first page of BRE Digest 251. You can see the top right-hand corner. This is the latest version, hasn't been revised, and I don't think it really needs to be revised. It says all it very successfully what it needs to say. 1995. Now I've scribbled on the top there that it was first published in 1981. I did get an archive copy from BRE Digest. It's much the same, but it's not quite as neat and presentable. Was revised in 1990 and then revised yet again in 1995. It says it assesses damages in the low-rise buildings. I've got a little graph at the bottom there, which is quite interesting. I probably can't see all the dates that clearly, but the little blip to the left-hand side is 1976 summer, which I remember my youth. I just left school, and that was a very hot summer. And when England were demolished by the West Indies cricket team. And the biggest spike, though, is from the summer of 89 and 90, with 2 dry years there. So that's a much even bigger peak there. So these are the number of claims. And so those were probably the years when people were still thinking, oh, there's cracking, we've got to underpin, without thinking very hard about it. So I'll probably go into detail of when you should or shouldn't do underpinning in a separate one about how you repair damage to the foundation damaged buildings. Right. The second slide here is, well, I think this is the essence of the BRE Digest, showing you how, on a very simple elevation, just give you a hand-drawn sketch, which I'll show you 2 instances later on at the end of this presentation, of 2 properties where I've done elevation sketches. Now, the 2 things is that you show here the direction of the cracking where it is. Now you have a solid line, a solid line shows an external crack there, and a dotted line, which I hope you can see that it's dotted, is an internal crack. So that is very important in deciding whether you have got the element of foundation movement. Okay, so there are a whole number of things which I'll briefly mention here. I'll go into more detail later on in how to determine whether you've got cracking due to foundation movement. Okay, so the first one is that you've got an element of movement going from the bottom right up to the top, which you have here. So you've got cracking that goes nearly down to the bottom, all the way up around the window side, between the windows, around the window, and up to the top of the roof eaves. You don't have it here, but the other point is that you have cracking on both the inside and the outside. So you can see that on both properties here, you've got a solid line and we haven't got a dotted line there, but you've got a dotted line at the top, which indicates to me, in a way, I mean, I don't know if this is a real property, it's just what is shown in the digest, but perhaps the cracking in this property here isn't necessarily related to ground foundation movement, whereas here it is, because you can see all the way up. You've got a dotted line there, you've got a dotted line, I think it is a dotted line there, and a dotted line here. Oh, that's interesting. That's obviously a gable wall of a house behind, or garage, I don't know. Anyway, and also is that the cracks are varying in size. So you've got cracks 3, 4, 8, and 6 there. Isn't it? And it's increasing in size there. So that they're all the indications that you have got foundation movement. This is a slide here showing the scale rule that I use to measure the size of cracks. So you can see, you saw in the previous video that you got the. So instead of using a tape to put up, this is a really handy thing. It's from Avon Guard, and I'll give a link to their website. Although it's such a unique spelt word that you just do a Google search and you find it. But they're fairly cheap. These rules, I don't know, about between 10 and 15 quid, and they give gradations of the crack width from 0.1 millimeters all the way up to I don't know, it's about 7.5 millimeters, I think, or bigger. Um, and if you're getting any bigger than that, well, you just use a tape. But it gives all the gradations of crack width. So, ooh, can I see which is 1 millimeter? Oh, I can't, my eyesight isn't there. I think it's about 1 millimeter there. So it's all those widths down there are less than 1 millimeter. So you can gauge the crack width quite easily, and so you're just putting the width of the crack line on that strip there, and then reading off. This photo isn't from BRE Digest 251, by the way. It's from the original book by the Institute of Structural Engineers, called Subsidence of Low-Rise Buildings, which I think may refer to in the reading list. It's been replaced by the current one, which is just called Subsidence. Uh, right. So going back to the digest, the other recording of movement are these two things here. So on the left-hand side, we have verticality. That's recorded using a plumb bob line. So when walls go out of plumb, and on the right-hand side, you've got the level plot. So I'll show you a photo of how you would do those two things. It's not something that I do very much. You'll only get it when you have quite very bad distortion of a building and foundation movement. I mean, in my time, 30 years surveying, I've only come across about 5 or 6 buildings that have had foundation movement, and I haven't needed to go into this degree of measuring. So to record the verticality out of plumb, you can see one chap up a ladder holding the plumb bob line, and a chap down at the bottom making sure that the plumb bob doesn't move out too much, and then measuring the distance from the wall to the plumb bob line, and then being able to measure its verticality or out of verticality. And then to get the levels, you can see there's one chap there at the building. He's got what's called a leveling staff. I don't know if people watching this have done any leveling in their surveying courses. And this here is a tripod on which I would think a dumpy level is. But of course, the way the photo is set up, you can't see the dumpy level. But that's how levels around a building are measured. Once you've got all that information together, so for the crack pattern on an elevation, and for the verticality, and for the out of level, you can then give a classification. Okay. So this has been one of the criticisms of the digest, actually, that it's been so specific about the different levels of category going. So you've got 6 levels, and some people say it's 5 levels. No, because it's 6 because you're starting at 0 for some reason. So you've got category 0, 1, 2, 3, 4, 5. Now I don't know how well you can see this, but 0 is hairline cracks, 1 is fine cracks. So fine cracks means cracks up to 1 millimeter. Cracks easily filled, that means cracks up to 5 millimeters. Category 3, cracks which require some opening up. So they are crack width 5 to 15 millimeters, and then category 4, 15 to 25 millimeters wide, and then 5, which requires major repair, 25 millimeters or more. And as far as I'm concerned, you're almost talking about rebuilding there. Well, not the whole building, but of the large area. It's not something you could easily just tie together. Um, and it's not a very well presented table, I must admit. But if you were to do a Google search for BRE Digest 251, Table 1, you'd get, oh, I don't know how many apples, I should have done it myself and recorded, but you'd get about up to 10 different tables reformatted. One that I've had for quite a while is this one. You can see the kind of the watermark behind it, which is from Guardian Foundations, but it's a laminated thing. And I have taken it to site with me actually, and I've shown people, and I said, look, this is category 1. You've got very slight damage. You can just infill it. And what's interesting is that once you have given it this category, people, or have I said, but anyway, can get really concerned when they have cracks in their buildings. And I remember years ago, there was an elderly couple. This was when I was working for a loss adjuster, I working for the insurance firm. And I went along to view these cracks, and they were only, I think they were probably hairline damage, not in for the category 0, not even category 1, but they were literally having sleepless nights. They were really worried. And once you say, well, look, it is nothing to worry about, well, you hope that you'll satisfy them. Sometimes it doesn't. But what's interesting is that you can see here for category 0 and category 1, you've got a do nothing. So it's really, well, negligible damage, do nothing about. Category, because you can't even see them that well. Category 1, where you just repaint them over. Category 3, well, this is cracks, so up to 5 millimeters. So the smaller size, or when you can say you're quite sure that isn't foundation movement, again, there's a do nothing. And if you have got clear signs of foundation movement, then, well, you need to do more investigation, but we'll go into that in the next one. And then category 3, this is really the grey area. I would say the top end of 2 and category 3 is, we need to do something about it. So category 0 and 1, do nothing. Category 4 and 5, you've got something written there, and it could be well about to collapse. Now, I'm talking about to collapse. The only major, really bad foundation movement cracking I ever got involved in was 2 pairs of semi-detached houses in Brimau, which was due to mining subsidence. So that's here in South Wales, which we just don't get clay to scale. We aren't in the band of highly shrinkable clay. So those cracks we were monitoring them, and they were just increasing and increasing all the way up. And very soon, within a week or so, it was made a decision, because they were council houses. So it was decided by Blaenau Gwent Council that they had to be demolished, and as it were. So I think category 4 and 5, you're looking at significant rebuilding, if not demolition. And it was so bad that they had very quickly, I think even before we got there, had put up scaffolding against one gable wall. So yeah, get a good table, and by all means include this in the report, because it's got quite good summary. Now, the criticism of this is that it gives very strict definitions of the size, which is a good guide, but the problem is actually if in foundation movement, and we'll certainly see this on the slides that I show for this house in Brimau, there were a number of cracks all lining up, and each one was about, I'd say, 3 to 5 millimeters. And so if there were 2 or 3 cracks, you don't say, well, you measure each one, say each one of those individually. What you actually would do was measure up each crack. So if there are 3 cracks at 5, well, you've actually got a total of 50 millimeters of movement. So whereas you think you're in this area here, actually you're in that. So that's why it's not necessarily you keep to that rigid way of looking at it. You have to be flexible, and you have to think, what have we got here? What movement, and how bad is it? Now, as I said at the beginning, the BRE Digest for me is essentially how do you record um, and give that recording, that evidence in your reports with those elevations and plumb surveys and level surveys. Although I said I only do the elevation sketches of the cracking. It does, and this is from the 1, 2, 3, first from the 5th page, just above the table. It does start to talk about causes of damage. But I would just caution, I would never use this digest as being the be all and end all of how to assess damage. It gives you a start, an indication. So as we go on in this course of videos, I'll give you a much more fleshing up to it. So it says, under reporting of it has been discussed that, it's the cause of the damage and whether it will be progressive that is of great concern. Um, so the next part, so this is just a small blow. So interestingly, it does talk about causes. You can see at the bottom there, it talks about with movement, say with the ground, but it talks about what in the structure has caused it. So it's interesting it does it that way around. Because whenever I'm assessing movement in the building, what I always do is look at, is this pattern of cracking indicative of foundation movement? That's the very first thing I want to do. So I'm always looking for those 3 or 4 things. I think, does the movement go from ground up to roof? Is it found both on the outside on the inside? Has it got a kind of a slope diagonal nature to it? Do the cracks vary? Are they small at the bottom and larger at the top, or sometimes the other way around? Yeah. So it talks about, again, it just gives and another indication that it's just really skimming over the subject. It just gives 4 different categories. But in the book I've got that I said was really good, which is Cracking Building Movement by Peter Dickinson, or another BRE Digest, I think 368. There are about 15 different causes of movement. So this, well, not necessarily that, but material shrinkage and create. But I mean, the most common cause of cracking I've ever come across, and we'll see this in the later slide at the end about one house, where the surveyor thought it was foundation movement, it clearly wasn't. It is due to expansion and contraction of the masonry, be it brickwork or concrete blockwork, and basically too strong a mortar being put in, and there not being the right or not being any movement joints put in. Corrosion and decay. Well, that's if you've got steelwork embedded in there. It could be you've got some reinforced concrete elements, and you've got spalling of the concrete due to the reinforcement and expanding. Differential thermal with dissimilar materials. Well, certainly you can get that so with render. If that covers different materials, that can be happening there. Poor detail design and workmanship. Well, I suppose that's kind of thing that would get covered by putting too stronger a mortar, which is what we'll see in the house that I surveyed that I'll be showing. The surveyor thought it was foundation movement, and it was not. So next slide. We'll talk about all ground movements. I've come across one due to mining subsidence around here. And does it say about? Doesn't even say about the one that is. Um, here. Well, not chemical attack, but no, it doesn't even say the one that I find mostly, which is due to escape of water. So that's the one you get most in the southeast. So clay soils. So I don't find that at all, but I know about it. So I'll be talking about that specifically in one lecture all on its own. Um, and so if you're on fill, so that's the typical type of. So if they haven't done a proper site investigation, and they've just put the foundations on badly compacted material. So it's very brief, the discussions there, but it's a starter. And I say, don't think that you've learned everything by just reading that. This figure from BRE Digest shows three different modes of how the building can move, distort. Um, I've certainly found cracking due to the top one, where it's sagging, so it's a bit like a beam being loaded in the middle and it then deflecting down. Basically, that's the one with the mine substance in Bramau, where we had to demolish the house. So the ground had basically just there was an old iron ore roadway that had collapsed. That's what we think it was. There certainly were no records of any coal minings, and it just collapsed. So the bottom fell out, as it were. So the amount of movement correct. I have never come across it, and I have no idea how that can occur. Um, yes, that's all I can say. I think it's just a theoretical one, and this is a classic one. Where just the edge of the building gets affected, so either by a tree here, and you've got clay soil there, or you've got a leaking gutter there, or you've got a drain that is so the water is escaping out of. If you get the old salt glaze drains, so they the ground moves and they don't have very good watertight connections between them. It's just, they're just one bit goes over another. So it's like that, you can see. Um, Whereas modern plastic piping has a rubber seal around it, and you get a much, and they stay watertight even when you do get some ground movement. So you're just getting the end of it affected. So it's acting a bit like a cantilever, and it's sagging down. So this is in a way the rest of the building is just corbelling out, and that's just collapsing away there. That's how that works. Right, so on to some actual buildings with actual cracks. So we are really getting into the nitty gritty here. This is a house I looked at, I don't know, about 3 years ago now, actually. One of the rare ones that does have some foundation movement, but not a great amount. I mean, even at this distance, you can't really see it because there is cracking is up there. I can't remember if I put a closer slide on, but we'll find out. But what was the interesting thing here was when I came to do the elevation sketch for the people who owned it, um, it was difficult one to get a photo of it because this great big this garage here is stuck in the way, and it's obviously later. It was a 1950s house, and so it's hard to get a distant view of this whole elevation, actually. So what I had to do was to take all the measurements of all the distances and certainly best inside, the position of all the windows, so I could do a full sketch. Well, I'll quickly go to it. Oh, it's there. So I haven't got a sketch of it. So here, this was part of the elevation that was obscured by the garage. So what it did reveal is, and this is how it was built, how originally there's so many windows and doors all together. that it just really weakens the whole structure. So it was, I suppose you could say, a structure that's crying out for it to be cracked, but I need a slight amount of foundation movement. Back at the photo, there was a tree around here. And well, there were two structural engineers of all things who'd been to this property before me, um, and they both said that the cracking was due to this tree extracting water. Now, as I said, well, firstly, we don't have, there's no shrinkable clay in Abergavenny. It's all glacial clay from the, no, it's glacial remains, which is mainly gravel surrounded by clay and sand. So there is a small amount of clay there. But one, there's a very small amount, and two, it is not highly shrinkable. Um, and secondly, I could not see how this tree could extract water from the ground around here and not affect this structure, this part of the building at all. Because if the tree was over here and it was extracted, it's going to do more damage to the subsoil here than where it is cracked. And there was no cracking around here. So I just and funnily enough, they had also done a drain survey. So you've got a downpipe here, and you've got drains that run along the back of it, and they found leaks all over the place. So um, that was obviously the cause of it. And actually, interestingly, I did contact the well, yeah, the person who lived in the house back in the 60s and 70s. And she said, because she was living in Australia at the time, I got just amazing how useful social media can be, because I just did a quick search, I think a Google search, and then it came up that she had lived there, and she put a request on Facebook, says, does anybody know about what's happening to this house? Because her sister, who does live here still, went past the house and saw how it wasn't being looked after because the person who was living there had died, and was well, no, he was in a care home, and then she died. But that's a long story. But anyway, so she wanted to know more about it. So I got contacted her, and she said that her dad was constantly rodding the drains along there. So that just gave me another indication that it had been leaking water for a long time. So you can see here, I've just put it, so you've got solid line for the external cracks, a dotted line there for the internal cracks, something there. You've got it going from the back. Well, now the interesting thing is well, people might say, well, you've only got the crack starting there. Well, because what you've got, these sides, what we call jambs of the door and the window, they're what we is called the free edge. So that's where the movement can just go around. So you can say, well, it could start there or there, go up and around, and then start visibly there as a crack in the building. And then the movement goes along that free edge and that free edge, and then along there and up to the top. So that's all that's a classic sign of foundation movement. It's not very angled, so it's almost in a line up and down, but it's angled slightly there. Now then, this more recent job, this is only about 2 years ago, and I do this. I'm doing this distance shot here because it's something that on a lot of Facebook, even by surveyors on the Surveyor Hub community thing on Facebook, which is all RICS where you'll get a close up of a defect or a crack. And I says, well, I don't. Well, okay, it's nice to see that, but I also want to see something further back so I can get context. And I've done this purposely so you can see that it's two. It's a mirror image. We've got two houses here, so if it's the so you've got a party wall down the middle there. So it's always very useful when you've got that, because you can say, well, if I got defects and the cracking was found down the side, each side of this garage here, because it's on, well, you can see sloping ground, so the ground is higher than it is here. And so they use that to, cleverly form a garage here and have a little balcony there you can sit on. Which, interestingly, the people there have also adapted and extended the roof, um, which makes sense because they put in French windows, because you've just got that which you have to go outside. And I don't know how you get there. I think you get, because that's the front door. You can't get to it from there. I think you have to get it from the other side. Anyway, so it's looking at, because I did find it on the other house it's cracking. I said, oh well, it's happens twice. It's a bit like going to the doctor. But have you had this happen to you before? He says, yes. Well, you've got it happening again. Um, so, but it means that there is, if you can come to reason that it's not a unique cracking to that property. Um, so this is closer up of the house itself. So whenever I see a property, and lots in Abergavenny, with this type of, and I find it quite, yeah, what I call pretend stone. It's reconstituted stone. So it's basically a cement, it's a concrete base with a small aggregate. And it will be, they've got different colours here to make it look a bit different types of stone, and it's, oh dear. And it's got a rough edge which may be formed by it, but it's, as I say, it's just cement with a small aggregate, and as soon as I see that, I said, oh, I know, I'm going to find some shrinkage cracking here, because what the builders do, and I don't know this for sure, I am just guessing that when they see this, they somehow think it's stonework, which is really strong, and they says, "Oh, Bill," he says, "What is it, Fred? We've got to make some really strong mortar, for this because it's strong material, which is the worst thing in the world to do." And yeah, you can see in the photos that they make it so strong that the concrete block work, which is what it effectively is, has cracked instead of the mortar because it's stronger than the mortar. And this is one, interestingly, where the surveyor said he thought it was due to foundation move. Didn't refer to BRE Digest 251, didn't do any uh, elevation, cracking pattern, as is shown in 251 at all. It doesn't surprise me very much. So it is a closer one. And there you can see the cracking going through the block there. It did confuse me a bit because you have got this cracking in the rent. So up here, I imagine it would be just simple concrete block that is rendered. This diagonal cracking, and again you can see it's been repaired a few times, but all they've done is to infill the render. They've never gone back to the um, to the concrete blockwork behind and repaired that. So you've got cracking always in the block. And the fact that you can see that this is an almost vertical crack there, and you've got a crack there. And also, so what tells me straight away is that this is not due to foundation movement and is due to thermal shrinkage expansion. So something, movement occurring in that axis, is that all the cracking is in the perpen joints in between and there's no real cracking along the mortar bed. So that tells me straight away movement is across there. And then I think that's just a bit lower down. So you've got crack there and a crack there. It's quite amazing that have got two vertical cracks so close to each other. And this is on the other side. So again, you can see the cracking there, but there's barely any movement there. So again, although it's stepping down and giving one partly an impression of this foundation movement because it's diagonal. For it to be foundation movement, you've got to see all these things, and which, as I said, it's not just the size of the crack or the increase in size, or the fact that it's diagonal, but you have to see on the inside as well as the outside, and this wasn't on the inside. I haven't got any photos, but there was no cracking on the inside. So when you come to now, I put this up because this was a sketching I was doing on site. So you just need a quick, hand-drawn sketch. You don't need anything that fancy. Um, I've got, dimensions here. So when I come to draw it out, I can, do it roughly to scale. So that's on the side that we saw just by the steps, and this is the other side. So where we had the crack, and with the crack width there, and then this is the sketch that actually went into the report. So it's tidied up a bit and put onto one sheet of page. So it's just basically it's a hand drawn sketch with the kind of ruler lines to give a guide to where the ground and the walls go, with the crack sizes on there, and all the lines that you can see are solid. There's no dotted lines. So this was a cavity wall. Um, so that was a clear evidence that you had a shrinkage and expansion cracking and not foundation movement. So there you have it, a good run through, quite a thorough indeed run through BRE Digest 251. I have added, as I said before, in the description to this video, a link to a report I did, so you can see how I showed all the cracking for that building house with the cracking in the garage walls. So hope you enjoy this, and hopefully it won't be 3 months until the next video. Thank you very much. Bye.